Last two questions. I'm going to scroll way to the end. Almost there. All right. This is a question on your test. It looks just like this. And at the end of the day, you're trying to solve for H. So I'll let you look at it for a second. That's exactly what you have on your paper. Mine's just a bigger picture. What do you do? What? The only thing that's missing that could possibly maybe add a little bit of student input is that. Yeah, but it doesn't do anything for you, really. Okay, so this is you on your test tomorrow. So, no guessing is wrong, but guessing could lead us somewhere.
You solve for...
We're trying to solve for H.
Solve for the third angle.
So we do know geometry states that this angle is
65. Can't you just do a Pythagorean theorem?
85 degrees, because 95 plus 85 is 180. Okay? You cannot do Pythagorean theorem because it's not a right triangle.
No, wait,
No, I was trying to solve for the left side.
Okay? We added 85 degrees. That should theoretically get you going in the right direction. So what's the stumbling block here?
Solve for A.
Okay, you can solve for A, you can solve for B. Either is a good option. Pick one. A. So if I'm going to solve for A, I have 3 angles in a triangle and I have one side length. So I can do the sine of C over side C, which is equal to the sine of A over side A. That's using the law of sines to find this missing value. As you cross multiply, 100 times sine of 25, 100 sine 25. Cross multiply the other direction, A times sine of 85, A sine 85. Okay, some of you guys are getting stuck here. How do you get A? Divide by sine of 85. So these cancel out, and you're left with this mumbo jumbo equals A. Good thing your calculator will do that for you. Control divide. 100 sine 25. 100 sine 25 divided by the sine of 85. Boom! 42.4233. And what do the instructions say?
Meters, thousands.
Thousands. That's 3 decimal places. 42.423. Cool. Cool. Do I have the answer to the question?
No.
What is H?
Now can't you solve using the angle B for H using 90 degrees? Oh wait, and the hypotenuse of that triangle?
Well, this is 90 degrees, and I can solve for H by using just regular trigonometry.
Yeah.
Sine. Now, to solve for H, the sine of 70 degrees is equal to opposite over hypotenuse. What happens when there's a number on the bottom? So 42.423 sine 70 equals h. Yes, sir. Because sine is the only trig function that will solve for h. The sine function is opposite over hypotenuse. I'm looking to solve for the opposite value, and I do have it on hypotenuse, so I use sine there. Okay, I'll do it. 42.423 sine 70. 39.865. 39.865. So that is the only answer that I'm looking for. 39.865. Yeah? No? Maybe? Does that make sense? So you have the answer in your paper, right? Yes, 39.865. Now, I'm going to show you this one more time, but I'm going to go the other way just to prove that it works. So you don't have to watch this, you don't have to write this. You have to watch it, but you don't have to write it. So watch the process. 39.865. Theoretically, that's the answer. So if I was going to use this number, we already discovered this is 85 degrees. So if I wanted to solve for b, the sine of 85, law of sines over 100, could be equal to the sine of 70 over little b. So when you do all the simplification process, you end up getting 100 sine 70 over sine 85. So I'm going to evaluate that. 100 sine 70 over sine 85. Completely different answer. 94.3282. Okay, 94.3282. Now that I know that this is 94.3282, now I can use this angle. It's still the sine function. The sine of 25 is equal to opposite over so now it's 94.3282 times sine of 25. Oh man, it is the exact same answer. The exact same answer. So if you had time to double check your work, you could do law of sines and find both sides and trig it, it would still equal h in the middle. Okay? Don't do it twice, you'll be expected to do that once on your test. Once. There's one question just like that. Alright? The other one looks like this. And here's my gift to you. All you have to do is solve for angle A. Nothing else, just solve for the one angle.
That's that law, right?
So the law of sines, you have to have at least two angles. The law of cosines, if you have three sides, you can use that one. So if we're solving for angle A, we have to use little a. So just memorize that. When you see this question on your test, you're using the law of cosines. Little a, so a squared equals b squared plus c squared minus 2bc cosine of big A. Alright, we just fill in the information. Remember, Baker likes to label what he has. This is little a, this is little b, and this is little c. 9.2 squared equals 5.1 squared plus 7.8 squared minus 2 times 5.1 times 7.8. Cosine of what I'm trying to solve for. Good thing it's printed on your test, right? The formula is printed on your test. You're just filling out information. And then you have to match that into the calculator. So you can do this step by step by step by step, or I showed you the cheater method. Which one do you want to see? Okay, so make sure you understand what's going on. I'm going to ask you for a few numbers. Help me fill it out. So when you're using the cheater method, we're doing menu, algebra, solve, right? Menu 31, that's going to solve it for us. We type in exactly what we see on our paper, which is 9.2 squared equals 5.1 squared, 7.8 squared, I got a mirror, minus 2 times 5.1 times 7.8. The cosine of the angle we're trying to solve for, we called it A. Close your parentheses. That ends the equation that I'm trying to type in. And then you hit comma, calculator, please solve for A for me. So you have to end it, close it off, and then tell the calculator to solve for A. 88.4 degrees. Alright, what do the directions say? Round to the nearest degree. 1,000. Well, so 88.408 would be your answer there. So the hardest part here is filling this out. And then 88.408. So two of the more difficult questions on your test. Two of the more difficult ones. Everything else are simple processes, but it's complicated to distinguish which process to use. Do I use trig? Do I use special right triangles? Do I use Pythagorean theorem? Can I simplify a radical? So here it is, right? We have 30 minutes, and there's 36 questions. What do you want to see? What do you want to look at? Yes, ma'am. You want to pick a number? See, you weren't here for that yesterday? Okay. Well, we can do 33. That's kind of at the bottom. We have some space to work. Please realize that these two questions are tied together. I don't know if y'all saw that or not. So number 33. A pilot is flying at 10,000 feet. This helps me just kind of. A pilot is flying at 10,000 feet.
Didn't say anything about the plane.
I would assume he's flying a plane. Otherwise, he's flying a UFO.
Yeah, it looks like
There is a hot air balloon. At 9,000 feet. Now, I don't expect you guys to draw these ornate diagrams on your test. That might take you too long. The angle of depression from the plane to the balloon is 30 degrees. All right. Now remember that an angle of depression is from a horizon line down. So the plane is flying in a straight line. That's going to be our horizon line. The angle of depression from here to here is 30 degrees. I was kind of clear about that, but I don't think you guys got a lot of practice with that yesterday. And it says find the distance from the plane to the balloon. So we're looking for X distance right here. Now you can connect a line right there with the right angle. And you should be able to justify if the hot air balloon's 9,000 feet in the air and the airplane's 10,000 feet in the air, what is this distance right here?
1,000.
So the angle of depression is 30 degrees. But what is the angle inside the triangle?
60.
So 60, 90, 30. So you can use trig here, you can use special right triangle tricks. How do you get from a short leg to a hypotenuse? Times 2. So the answer here is 2,000 feet. 2,000 feet is the diagonal distance from the hot air balloon to the plane. You can use trig there, that's fine, I don't care. But special right triangle tricks are a lot faster. So what I skipped, I'm hoping you guys can start to pick up on this stuff, is if this angle's 30, this is where I start, right? I always put a star right here. 1, hypot, 2 nous, and then the square root of 3. So how do you get from 1 to 2? Times 2. So 1,000 times 2 is 2,000. It's a good one, right? Did anybody use like 30 right here on accident? Yeah, it's just they're small mistakes. On your test, it's just going to be one of them, and it's going to ask you kind of like talk about this picture right here. It'll say like, what is the angle of elevation? What's the angle of elevation right here? 28 is the elevation angle. What's the angle of depression? 42. Pretty much, yeah. Remember I drew that like bow hunter guy? It's a picture like that. Good question. Did that help you a little bit? Okay, anything else that we can go over? I know there's more. If you want to like check one, like I'm not sure about this one, Baker, you want to walk me through it?
Well, it's like I should know how to do them, but I just like cannot remember like 8.
So, can we identify what this question is? Okay, so when you say it's a right triangle, that means I could be mathing by Pythagorean theorem, by trigonometry, or by special right triangles.
But it's a 45, 45.
Okay, so if you can see that it's a 45, 45, 90 triangle. This is a 45, 45, 90 triangle. This is a 45, 45, 90 triangle. And this is a 45, 45, 90 triangle. And it's also similar right triangles. So you could say that like, remember this one? X over 1 equals 1 over y. Do you want to do that? No, nobody wants to do that. Okay, so if I just look at this right triangle right here. If the leg is 1, how big is this leg? 1. If this leg is 1, how big is this leg? 1. So now I know that the hypotenuse is 2. This hypotenuse is 2. So now I'm looking at the big right triangle. Also 45, 45, 90. How do I get from here to here? Divided by the square root of 2. The other one is also the square root of 2.
Felt very strange just having like a radical.
It's okay, and you can always double check the square root of 2 squared plus the square root of 2 squared equals 2. Squared.
Yeah. So
Square root of 2 squared plus, yeah, the square root of 2 squared is 2. Square root of 2 squared is 2. 2 plus 2 is 4. 2 squared is 4. Ooh, lots of squared. Yes. 17? 7.
Yeah.
Draw a rectangle. You good there? Okay. The lot is 165 feet long. It is 90 feet wide. And we are looking to make a diagonal fence. How many feet? Round to the nearest foot. You have trouble like trying to simplify a
No, I
radical?
just wanted to make sure I got it right.
Yeah,
I
so
didn't know.
9, and this is not a special right triangle. It's not not a trig question. It's just straight up Pythagorean theorem. 90 squared plus 165 squared equals x squared. And I told you guys you could the square root of adding the legs together. The square root of 90 squared plus 165 squared rounding to the nearest foot is 188 feet of fence. So do diagonal.
So that's like, I'm not.
Yeah. I mean, I hate to say the S word, but it really is that easy. But it's hard to figure out what you're supposed to do. Yeah? Just me? What else we got?
8 through 13. I just like cannot remember.
Okay. Ooh. All right, might want to write this down somewhere. Well, we did this. This should have been part of your notes already, somewhere. So if the if c squared is bigger than a squared plus b squared, it makes it a obtuse. So I know we had some was it 6th period? Or was it this class, right? It was a little discussion. Obtuse. It's easy to switch them. So now if c squared is less than a squared plus b squared, acute. And then this one's weird. If c squared equals a squared plus b squared, yeah, that's Pythagorean theorem.
Oh,
Correct. Wow, I was this many days old and I remember that. So this is all pretty much calculated. The only thing you can really screw up is if you pick the wrong c value. So 9 plus 25 is 36. This is 49. Is 49 bigger than 26 or smaller? So this is obtuse. Now I know I'm doing math in my head. You have calculators that can do that for you.
I did opposite.
So yeah, it's easy to switch. Does that clear it up, or you want to go through all of them?
Just do like one more. One of like the dumb ones with the radicals.
Number 12?
Sure. Oh no. Oh, it is.
What?
It's a right triangle.
Are you sure? Watch.
Yes, because 3 plus 3 equals 6.
3 plus 3 equals 6. This one's a little weirder though. Right, the radical here. So you can kind of math that in your head. 5, the square root of 5 squared is 5. 4 squared is 16. 5 squared is 25. So is 25 bigger or smaller than 21? So this one's also obtuse. Hey, guys, just being comfortable with the uncomfortable parts of mathematics. Good conversations. Yes. Anything else you want to look at? Yes, sir.
19.
Number 19. I know why. Okay, so remember, always put a star at the 30 because that's where you start. Right? So you start opposite of the star. 1. Hypotenuse. You could use trig here if you wanted to. The only problem with using trig here is it's going to give you a decimal answer. And no decimals allowed. You have to leave it in the radical form. So how do you get from the square root of 3 to 1? Divided by the square root of 3. Now here's how you think about that. The square root of 3 divided by itself equals 1. The square root of 3 times the square root of 3 is 3. So I have to take this number 12 and divide it by the square root of 3. Now, math error, can't do that. So you have to multiply it by 1. Okay, 12 times the square root of 3. The square root of 3 times the square root of 3. And then keep simplifying. What is 12 divided by 3? 4. Square root of 3. And then you're halfway there. How do you get from the short leg to the hypotenuse? Times 2. So what's 4 times 2? And you get it, you're just not comfortable with it. And then I'm going to take the training wheels off, throw you in the deep end. In 49 minutes tomorrow, because we're on pep rally schedule. Yep. I took 3 more minutes from you. That's why I gave you that paper with 2 free test answers on it.
Was it
20. It's actually 29.
Actually, what?
29. Because question number 23 is fill out the unit circle, all of the radians that are missing. And then question number 24 is 5 parts, like what is the cosine of 2 pi over 3? Find the exact value.
If the unit circle, is it just a part of
The whole thing.
the full?
Kiss that A goodbye.
Wait, how did they go again? Was it cos
You want to talk
sine?
about that?
Yeah, can
You want to talk about the unit circle?
Yeah. Wait, no,
Only if
not-
you
not the
review.
unit circle, like
What's this?
the,
Okay, I know where you're going with this, Hallie.
you know, it's, yeah.
All you have to know for the unit circle is if you know 5 things, you should be good for the coordinate locations. You know 5 things. So over 1, up 0. Over 0, up 1. Okay? And you count on the right side where all the Y's are, all the right ones. 0, 1, 2, 3. Left side, 0, 1, 2, 3. Everything gets the square root except the ones. Every other quadrant is a reflection of that one. Every other one is a reflection of that one. So if I wanted to do, is my y value going to change? The y value will stay exactly the same. So that's just drawing these 2 connections, these 2 connections. Is the x value going to really change? It's just going to become negative. So instead of it being positive square root of 3 over 2, it's going to be negative square root of 3 over 2. Instead of it being positive square root of 2 over 2, it's going to be negative square root of 2 over 2. Instead of it being positive 1/2, it's going to be negative 1/2. So you can really copy them down. X values don't change, Y values don't change, just the sign changes. That's why this is the negative positive quadrant of the unit circle. The only thing that's going to bite you in the butt is labeling the radians. Because you have to know what radian is what. Or you can convert it to degrees because you're more comfortable with that. And then you can go find it on the unit circle and then give me its coordinate location. And it goes cosine. So the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 6 is 1/2.
What are the radians again?
You want to go through all of them?
Oh, that was perfect circle.
It's forever on YouTube. Only if somebody watched them.
I will.
So we have 3 divisions in each quadrant. I like to start with quarters. So I'll do those in black. 0, pi. That's easy. What's half of pi? So I go 0, 1 half, 2 halves, 3 halves. And that should give you checkpoints. Then I like to do the 45s. The 45s are quarters, right? What is half of a half? A quarter. So 1 pi over 4. 2 pi over 4s. 3 pi over 4s. 4 pi over 4s. Checkpoint. 5 pi over 4s. 6 pi over 4s. Checkpoint. 7 pi over 4s. Then I count my pi over 6s. Make sure you don't skip anything. I don't know how I want to do this. 1 pi over 6. 2 pi over 6. 3 pi over 6. Half. Checkpoint. 4 pi over 6. 5 pi over 6. 6 pi over 6. Checkpoint. 7 pi over 6. 8 pi over 6. 9 pi over 6. Checkpoint. 10 pi over 6. 11 pi over 6. And then I can go back and add all my pi's.
Will you accept them in sixes or will you want them simplified?
You can, I am not even asking for degree measures, but then I might say, hey, what is the cosine of 5 pi over 6? And I want you to be able to tell me that the cosine of 5 pi over 6 is negative square root of 3 over 2. The calculator will only do it if you know what the degree equivalent of 5 pi over 6 is. So you have to know that is 150 degrees. Like, Baker, how do you know all this stuff? The first day I taught you the unit circle was the first day I ever learned it. I've done it one more time than you have. Once in 3rd period, once in 6th period. I'm one day ahead of you. What else do we want to know? 20 and 21. You can just like put that on repeat in your headphones and go to sleep listening to that. Only if I got paid to put kids to sleep.
Yeah.
That'd be a millionaire, right? 20 and 21. So, what are we trying to do here? Pythagorean theorem, special right triangle, straight up trigonometry, law of cosines, law of sines, trig. This is trig. So you asked 20 and 21, right? So which trig function do you want to use? There's only one that does not use the hypotenuse. Tangent. So now I know tangent. Tangent of the angle is equal to opposite over adjacent. Right? And you can use this, right? Opposite over adjacent. Five goes to the front. 5 tangent 45. What do we get for answer there? It is 5 tangent 48. That's what I said. Oh, no one did it? 5. What do the directions say?
The nearest 10.
Nearest 10, so 5.6.
Wait.
No? Was I wrong?
No, you're right.
I don't have the directions.
No,
What'd you do? The nearest 1,000?
No, I put 50 instead of.
Uh-oh. Yeah, so I make a lot of silly mistakes by typing the wrong angle in or not the wrong number. That's probably the biggest way to lose points. Let's try 21. Josh. You see X, right? You see it there? So you have to know what 11 and 23 are. Sometimes it's easier to say opposite, adjacent, hypotenuse. So you have an opposite and hypotenuse that should tell you what function to use. Sine. Sine is opposite or some old hippie. Solving for x. You're solving for an angle. What kind of sign are you going to use? So when you're solving for the angle x, you have to move sine over here. So if you had a smartphone and you want to try this at home, you could do it kind of like this. 11 divided by 23. And then you could divide it by sine. But my calculator is too smart for that. But your phone is dumb enough to do that. But here's what we're trying to do. The inverse sine. The inverse sine of 11 divided by 23. 28.6 degrees. Let's say nearest whole degree. So 29 degrees. 29 degrees. Yes. Yeah. $24. So, what trig function did you pick? Cosine's correct. Remember, makes like a C for cosine. The cosine of x is equal to adjacent over hypotenuse. One of those cosine things, it should always be less than 1. So when we're trying to solve for x, we move cosine over. And we type in inverse cosine of 6.5 divided by 10. We have 49 degrees. I just divided 6.5 by 10 in my head and put 0.65. Cool?
Could you, I did it a different way, could you just, for the 60, or 6.5 over 10, can you just divide them together first and then do, like,
That's what I did.
Oh.
But you know, most people like just to do it like the least amount of stress possible and type it all in. Still gives you this and exact answer. Doesn't matter. Yes.
Could you do some of that, like, the bottom part?
Yeah, which one do you want to look at? Number 30. A surveyor is 300 feet from the base of an apartment building. This distance is 300 feet. The angle of elevation to the top of the building is 24 degrees. And the surveyor's angle measurement device is 5 feet off the ground. It's a little tricky there. 5 feet off the ground. Find the height of the building. So when we use this 24 degrees, it's only going to solve from here to here. So if we're looking for this height, we can do the tangent of 24 degrees is equal to opposite over adjacent. And you get 300 tangent 24. So that's the height of the building. from where the surveyor's device is to the top, 133.56 or 133.57. And you still have to figure out the extra 5 feet, so it's 138.57. So there is only one question like this on your test that has to do with elevation depression, and I'll show you what it looks like. Remember that whole question about the tree and the shadow on your last test that y'all guys killed? Guess what? It's coming back. Here's a tree and a shadow. Baker pauses for applause, okay? The sun, the tree casts a shadow. It wants to know what is the angle of elevation from the sun, or what is the angle of elevation from that is created by the tree and its shadow. And it'll tell you that the tree is 4 feet tall and the shadow is 10 feet long. Yeah, clicking. So it would be the tangent of x equals 4 over 10, or the inverse tangent of 0.4.
That's the elevation.
It's gonna be like.
Yeah, it wants to know this angle right here.
And then your answer.
That's the answer. Yeah, yes sir.
Maybe they just like straight up word problems without or like
I hate word
The first 12 questions are all right triangles with some sort of Pythagorean theorem, special right triangles, or trigonometry. Or really, yes. The next two are, there is one word problem. A slide 4.1 meters long makes an angle of 35 degrees with the ground. How tall is the slide? Find the angle of elevation from the sun if the tree is 10 yards tall and casts a shadow 14 yards long. A right triangle has a hypotenuse of 60 and one side of 24. A right triangle has a hypotenuse of 60 and one side length of 24. Do the side lengths form a Pythagorean triple? So it says you have a side length of 60 and a side length of 24. Do all three side lengths make a Pythagorean triple? What I'm asking, are all three side lengths whole numbers? If you solve for the missing side length and it's a decimal, no, it's not a Pythagorean triple. Right? Maybe? It's a right triangle. The hypotenuse is 60. This one's 24. I'm not done yet. Oh, that's not a whole number. So do the side lengths create a Pythagorean triple?
Wait, is that the answer?
54.99 is not the answer.
No, I know what I was asking. Like, is that like? Are you like?
No.
It's a yes or no question.
No.
So no.
No, that's not the answer.
I'm confused.
Where is this from?
Test. Question number 20 says, you have a right triangle. The hypotenuse is 60. One side is 24. Does the third side create a Pythagorean triple? So that third side has to be a whole number. Is that a whole number?
No.
It's pretty close, but the answer is no. That's not a whole number. And you need to justify through what that means to answer yes or no on your test.
Why are you yelling?
I'm not yelling, I'm just really excited about mathematics. That review has to be completely completed in order for you to get the square root curve, which you might really want. It turns a 49 into a 70. Let me stop my recording.